Hello there. It's me again, Dr. Zero. Welcome to Volume 2 of this Kaizen video called Zero Breakdowns. What we're going to do now is look at practical ways to approach zero breakdowns. And we sure need some of those, don't we?
Here are the 4 basic steps to be taken as we aim for zero breakdowns. 1. Move from aggravated deterioration to natural deterioration. 2. Extend equipment lifetime by improving design weak points. 3. Complete implementation of regular maintenance. 4. Work towards forecast maintenance.
Well, they all sound sensible enough. But let us begin at the beginning with step 1. We've already explained that any equipment has a limited life, even if it's used properly and with great care. Over a period of time, the combination of load factor and time leads to both mechanical and chemical deterioration. This process is inevitable, and we refer to it as natural deterioration. Naturally. What we have to try to avoid is any deterioration that goes beyond this natural level.
Hey, Matt, when are you going to lubricate me, huh? I'm in a terrible state. I'm running out of oil, and I'm absolutely filthy. I can't take it any longer. I'm getting real burned up. I'm going to have a breakdown if you don't do something quick.
I'm sure you've all got the point. We all need lubrication. But not too much. If you don't lubricate as often as you should, and you leave the equipment covered in dirt and dust, you're bound to have defects and breakdowns. Do it properly, and you won't have breakdown. The deterioration you get from not using equipment properly and improper maintenance is called aggravated deterioration. And the last thing anybody wants is aggravation. In step 1, the point is to get rid of all that aggravated deterioration and make sure the only deterioration we have is natural deterioration. Excuse me, if I don't have a wash, I'm going to go crazy. Watch this example while I'm gone.
This is a diagram of a machine which shapes wire rods, such as this. The rack connected to the air cylinder turns the shaft, and rollers attached to the top of the shaft bend and shape the wire rods. In this example, if the operator is lazy about cleaning, iron dust from the surface of the rods gets pressed between the rollers and the rod being shaped, and can cause scratches as well as getting into the bearings of the shaft, where it can cause damage to the bearings. In addition, incomplete tightening causes looseness in the rollers and jigs, which can lead to the production of defective products. So, not only are daily cleaning and checking necessary, but proper lubrication and tightening as well. One effective improvement is to attach oil seals to prevent iron dust from getting into the works. By also installing a grease cup, you can ensure a regular supply of the necessary amount of grease to the bearings. These improvements to the equipment have a considerable effect in avoiding aggravated deterioration. As a result, the equipment will stop having sudden breakdowns and can be maintained in a stable condition. Here are some practical points to help us move away from aggravated deterioration back to natural deterioration. Restore all deterioration points which have been neglected up to now. Maintain all basic conditions for equipment operation: cleaning, checking, tightening, and lubrication. Clarify conditions of use for each piece of equipment and each part, and stick to these rules. Professional designers are usually responsible for designing equipment. Naturally, they have to check various factors about the ability, function, and structure of the equipment prior to starting the design process. However, it's necessary to bear in mind that most designers have not spent much time operating equipment themselves. Generally speaking, it is only the actual operators who really know whether the equipment is easy to operate or not, whether maintenance is simple or not, and whether the equipment is really reliable. Ideally, designers will get feedback from the operators which they can then use in the redesign of equipment. This process is called Maintenance Prevention Design, or MP. Feedback of information to do with operation, maintenance, and reliability of the equipment is very important in the process of design improvements.
Design, research and development. That's my baby. You know, I'm trying to improve this thing. I hope I have as much luck with this as I did at the factory. In fact, I can show you what we did at the factory. Have a look at two very interesting diagrams which compare the original design, which turned out to have weak points, with the improved design, which avoided those weak points. It's a before and after situation. So, watch carefully.
This is a cross-section of a device which transfers drive power from a belt pulley to a cogwheel. Bearings support the main shaft. Let's take a closer look at the original design for the space between the main shaft and one of the bearings. There was a groove around the edge of the main shaft to seat the bearings properly. But in fact, pressure between the shaft and the cogwheel concentrated stress at the edge of the groove. Metal fatigue occurred at that point and could easily have caused unexpected damage. Now let's see what happened when the device was redesigned following feedback to remove the stress problem. At the end of the shaft, a bevel ring was added to support the bearing better. This improvement provides better support for the shaft and avoids metal fatigue. Here are some ways of extending equipment life by improving weak points in design. Act immediately on weak points, particularly to do with strength and accuracy. Check the suitability of all parts for the structure of the equipment. Check for overloading.
Now for step 3. This involves the complete implementation of regular maintenance. Why? Well, the purpose of regular maintenance is to achieve an extension of the maintenance cycle and decrease maintenance costs by restoring all points of deterioration regularly. You see, natural deterioration has its own cycle.
By considering how to react to the natural deterioration cycle, and by deciding a suitable maintenance cycle, according to the equipment and the parts, you must implement your maintenance procedures, such as repairs and replacement of parts. By doing this, breakdowns can be avoided, and when equipment lasts longer, it's possible to extend the maintenance cycle of the whole factory. Moreover, because breakdowns are reduced, there is a drastic decrease in maintenance expense, such as repair costs. Equipment can be divided roughly into 6 systems. 1. The air pressure system. 2. The lubrication system. 3. The oil pressure system. 4. The drive and transmission system. 5. The mechanical system. And 6. The electrical system. For each of these systems, it is necessary to check whether individual parts themselves, and also the connections with other parts, are all as they should be, and implement repairs, adjustments, and replacements as necessary.
It all sounds very complicated, doesn't it? But it isn't really. To implement regular maintenance, in reality, means no more than deciding the proper conditions of the equipment with regard to these 6 systems. And then implementing checking procedures accordingly. What you really need is a checklist like this one. Let's give you a closer look.
This is a typical checklist for an air pressure system. It indicates the order of checking vertically and the places and items for inspection horizontally. There is also space for suggestions on necessary action. There are many boxes to be checked off, even for just this one system. This is the checking order. 1. The complete unit. 2. The filter. 3. The reducing valve. 4. The oiler. 5. The pipe joints. 6. The hose. 7. The hose clamps. 8. The direction changing valve. And 9. The air cylinder. Checklists like this for each system are invaluable in order to implement regular and efficient checking. In this factory, the schedule for regular checking is indicated on a maintenance calendar. This makes it easy for everyone involved to understand at a glance just which equipment should be checked when. Weekly, monthly, and annual checking schedules are shown separately. In addition, twice a year, outside specialists are invited in to conduct a total factory maintenance check. They produce a complete detailed list of results, which is very useful as a basis for developing new know-how for use in regular checking procedures undertaken by company employees. At this factory, they are constantly striving to gather information as a basis for improving maintenance techniques.
We can quickly find problem points likely to lead to breakdowns by doing regular checking, so equipment maintenance is incorporated into production planning, and stoppages caused by sudden abnormalities have really decreased.
Here are the main practical points for complete implementation of regular maintenance. Check and clarify life of equipment parts. Make checking standards, such as checklists. Set up standards for regular change of parts. Increase skills for maintenance techniques.
Now the last step. And this is very interesting because we're looking into the future. Got it? It's called forecast maintenance. It's more interesting than the weather forecast. More accurate too. It's a method for deciding the best time for maintenance based on the actual condition of the equipment. In other words, you've got to play for position. I'm going to shoot a practice round. But take a look at this person. He knows how to set up his play.
As you can see, I'm holding a revolution gauge. As the cogs of this grinding machine behind me turn, this gauge measures the revolutions of the shaft. In order to decide the cycle of checking for belt wear and tear, as well as damage to the bearings at an early stage, we have to collect data for a whole year to get an adequate picture of what's happening. We use gauges like this to measure data such as revolution loss and other variables.
The aim of this kind of equipment examination, no matter where you are, is to get an accurate picture of present equipment conditions. It should be carried out for more than 1 year, very quantitatively. Only then can you really pursue the reasons behind abnormalities and breakdowns. Then you can begin to forecast problems, foresee what state the equipment will be in well in advance. The beauty of this system is that you can construct appropriate countermeasures before anything goes wrong. As we pointed out before, we can often sense abnormalities at an earlier stage simply by using our 5 senses. But at this forecast maintenance stage in the factory, we must use various gauges for collecting data. And here are some examples. Slide calipers, micrometers, dial gauges, revolution gauges, pressure gauges, deformation gauges. These are all useful for collecting data. Forecast maintenance. Some practical points. Implement complete maintenance of equipment in order to get hold of reliable data results. In order to implement effective equipment examination, check whether the life of parts is more than 1 year or not. Clarify exactly what has to be measured and determine what kind of examination techniques and equipment are needed.
Well, what do you think? In order to achieve zero equipment breakdown, it's important to proceed with all 4 of the steps, and so implement improvements. I've done my forecast maintenance. So, while I'm playing, let's review the 4 steps.
Here are the 4 basic steps towards zero breakdowns. 1. Move from aggravated deterioration to natural deterioration. 2. Extend equipment lifetime by improving design weak points. 3. Complete implementation of regular maintenance. 4. Work towards forecast maintenance. And finally, here are 4 essential skills needed by every operator. The ability to find malfunctions. The ability to restore and repair equipment. The ability to know what is normal and what is not. The ability to maintain and control all equipment. In many workplaces, there is still a widespread belief that breakdowns are bound to happen. However, the alert operator should always be able to detect small indications of abnormalities before the onset of any defect phenomenon. What you have to do is spot these indications well in advance, reveal the unseen defects, and put the 4 points for improvements into practice.
Now you know exactly what to do. Please implement all the steps in order. And the result will eventually be zero breakdowns. And good luck with it. You see, it always works.
Lovely to bring. Very grown up.
I better get back to the party.
What, leave me here alone?
What did David say?
I don't know what you did to him, but I haven't seen him in such a state since he was kicked in the head by a polo pony at Old Westbury.
That's nice.
Amnesia has definitely set in. Completely forgotten he's engaged. He wants you.
And I want him. I've been in love with him all my life.
There goes the engagement.
It ain't a dress.
lovely breeze swept through this stuffy old house. How could I forget it?
Even though the breeze comes from the general direction of the garage.
Ah, it's the 20th century, Sabrina.
Thanks. Let's drink to that.
I'm sorry it isn't David here instead of me. But it's all in the family.
You know, when you just walked in here, I was sure you'd been sent by the family to deal with me.
To deal with you.
Like in a Viennese operetta. The young prince falls in love with the waitress at the Rathskeller, and the prime minister is sent to buy her off.
Buy her off.
Yes. He offers her 5,000 kronen. No, she. 10,000? No.
15,000 kroner.
No.
25,000 kroner.
No.
$25,000.
No. How'd $1 go into this?
$25,000 after taxes. That's a lot of money, Sabrina.
What are you trying to say?
I'm just trying to make it worthwhile. But the krona these days. No self-respecting prime minister would offer krona.
No self-respecting waitress would take dollars.
Good girl. Say, how does this operetta end? What's the last act?
I don't know. I guess they run away to America on a Zeppelin, with everybody singing like mad.
Open brewery in Milwaukee.
The love that made Milwaukee famous.
Prosit.
There it is. The song they were playing the night before I went away. David was right here, dancing it with somebody else. Tonight I wanted it to be me.
It's all in the family.
Oh.
How are we going to make sure that all the fragments have been removed?
Very simple. We will reconstruct the 2 champagne glasses.
Oh.
Now, I cannot possibly be hurting you. The area has been completely anesthetized.
It's not you, it's that song. Oh.
Sabrina. If David were here now, expect him to kiss you, wouldn't you? Here's a kiss from David. It's all in the family.
Come in.
Hi. Oh. How do you feel?
I never felt better in my life.
Oh, you look fine. The anesthetic worn off? Oh! I guess it has. Well, I brought you a present.
What happened on the tennis court last night? Was Sabrina mad because I didn't show up?
Not mad, just disappointed.
Kid. What'd you tell her?
The truth? The family objected to her, but you stood up like a man.
Good.
And sat down like a jerk.
23 stitches.
Yeah. This ought to make you feel better.
A plastic cabinet?
Uh-huh. With a trap door. Designed it myself. Ran it off at the factory this morning.
On Sunday?
Why not? You were in pain, so I had him open up the plan.
What out the process?
nice as I could be. What a brother. I've been trying to write a poem to her, but I can't seem to finish it. What rhymes with glass? Glass. Alas. Of course. Oh! Right on the nose. Silence! Sorry, David. Ah, Sabrina will only hear. Hey, how about smuggling her up in the dumbwaiter?